So today we're going to be focusing on a number of different things. We're going to be showing you actually how to use Famo.us, the new one we just put out this morning. So if you guys want to crank that up right now, you'll see a vastly different experience than the one that we had before. Before, we were teasing you and enticing you with the periodic table. It was almost intentionally a mystery. It's something inspiring and amazing, and if you looked at the code, it was all minified, and if you looked at the elements as they were flying by, it kind of looked like the Matrix. And it was really pretty cool, and part of the coolness was the mystery. But you know, we're here open, earnest, willing to show you guys how to be productive and build in Famous. Because we don't want there to be any mystery. We want you guys to be able to build your careers, or even just build your next site or your next application using Famous. And openness is the key to making that happen. So we'll also address some topics like the render tree. The render tree is something that is actually kind of different in motivation than something like you guys are used to using, let's say the DOM. In case you guys are like graphics programmers or game programmers, the render tree is actually much more reminiscent of the way a game, a game scene graph is put together. How many of you guys consider yourselves web programmers using DOM, jQuery, putting your site together and then adding some magic to it in a declarative way? How many of you guys are primarily native programmers, people who use a nib builder, who use Eclipse, and a visual style to wire things together, writing imperative code to support those interactions? How many of you guys are game developers? How many of you guys actually come from a game or hardcore graphics background? All right, we got one semi-confident guy in the back there. Good. So I can really say anything I want about graphics, and it wouldn't matter at all. Are you guys recording this? OK, fantastic. So we're going to be showing, we're going to be demystifying the main part of Famous, which is the render tree, which is actually how how surfaces, visual elements, are taken from the internal JavaScript representation and actually put on the screen. Right now, there's not a great bridge between what you want to build in terms of the render tree, specifying that tree, and what shows up. So a deeper understanding is required, especially until we build more and more of these developer tools that make that easier. So the render tree we'll demystifying the render tree a little bit. That will be a major part of the first lesson. Then we're going to actually take you through the first tutorial that we've written. How many of you guys have seen Famous University? How many of you guys have gone through all of the lessons in Famous University? How many of you guys skipped class and came here to cram for the midterm? All right, great. So I would encourage you to pay attention, although the lessons in Famous University for the first 5 aren't terribly long, and they do cover a lot of core topics. So we will be assuming that you've basically read those first 5 lessons. But of course, if you have any questions, feel free to ask, because we're all here to learn, and even simple questions can often be really revealing. And in the afternoon, we're going to kind of ad-lib a little bit more. We're going to be learning what kind of things work and don't work in this kind of audience setting. We put out Famous University, and that's actually gotten a lot of great uptake. Like in a controlled environment where you walk sequentially through the things that we're building and showing at the same time, we're actually seeing almost no one drop off. It's actually really cool and inspiring, and that's why we've invested so much, especially in under Shu, the dean of Famous University. It's kind of a party school, right? A little bit. But we're going to do a little more. We have prepared some lessons and some interesting topics for you guys. So we'll be going through layout and inputs, 2 pieces of the 0.2 framework that we've released since the initial version of 0.1. If you guys want to download 0.2 from GitHub, that's fine. But we're actually going to be showing you how to use our new starter pack, which actually makes this thing a whole lot simpler. We've updated layout and updated inputs because we found that these 2 from our community were the most needed and the most confusing elements of the initial platform, respectively, in terms of how to use them. So we'll be talking about those. We'll talk about actually how to build your own widget, a term we've colloquially used a lot to basically represent something that has its own sub-view tree that responds to events and that has a representation on the screen. And then we'll also be talking about going through building your own widget, but then also some of the demo tutorials that the demo packages that are available from Famous in our starter pack. So Shu, would you mind opening up the new famo.us site? Did you guys expect to see periodic table, or have you seen it since?
Seen it a few times.
You guys seen it a few times? All right, well, you probably haven't seen it like this because we just pushed this about 20 minutes ago for you guys. So a lot of the stuff looks pretty much the same. We explained a little more about what we're actually about. But if you go to the download button in the upper right corner, you'll notice a big difference. Before, how many of you guys had went through the Yeoman-based install process?
Wow.
That's a lot. How many of you guys started the Yeoman-based install process and didn't get through the whole thing? Okay, actually, I'm glad most of you guys. Yeah, thanks, Miles. Most of you guys were able to get through that. So this tells me that we have a more experienced contingent of engineers here. We go to conferences or we go to meetups and see people with a Windows computer saying, what's a terminal, and they don't get through that process so well. But we have a lot of belief in being able to build those tools, like the Yeoman generator for the more senior engineers like yourselves. But never hurts to have an actual .zip file with a minified JS that you can include right in your website. So the require paradigm still works, but we also allow you to just drop in, much like jQuery, Famous right into your site and be able to use exactly the same stuff. So let's actually download this bad boy. And you had it out, Shu?
Yeah,
all right. Good talk. What's that?
Let's see whether or not they can actually see it here from the back.
Can you? OK. Ooh, what's on this computer?
Yeah.
Can you guys see the cursor?
Just barely.
Just barely. OK. Glad you're sitting up front, dude. OK, so you'll notice that this is about 40 megabytes. But don't worry. The 40 megabytes is not for the actual online portion of the framework. This is a testament to just how much stuff we've crammed in here in terms of tutorials and the assets, especially for the community demos that have gone out. So let's open this up. And you guys, please follow along. It's designed to be actually really easy. Are you recording this bad boy? OK.
Use current. What?
Switch to beast mode.
Press that button.
It won't press.
OK. So we'll put it up on the screen in a moment. But OK, you guys actually, have you successfully downloaded the zip, all 100 of you at the same time from the network?
Yeah.
No? You guys are still going? 1 minute left. OK. Well, there's a lot of readmes in there, but I'll just sort of walk you through the top layer of it as we are downloading it and bringing it up for Shu. So we have the FAQ. You guys have seen that before. Nothing new there. That's, hey, am I using this framework for the right things at all? We have the reference documentation, which is available not just on docs at famo.us, but also something that you can actually use on your own computer. So clicking any of those will give, clicking index inside of 0.2.0 will give you a browsable, UE doc, JS doc generated set of all that stuff. You guys read code, so you can also just find that right in the comments. The guides from the site are in there as well. We'll be updating this periodically too. But some of the more interesting stuff, if you go to boilerplate and go to index.html, this is essentially our hello world experience, right? Like you guys have all written hello world in JavaScript, C, Python, whatever, and no one's surprised when it works. But it provides the scaffold in which you can actually add the rest of your application. So the boilerplate is a great place to start from nothing. If you actually go to interface demos, this is a great place to actually start from something. I wouldn't necessarily just take these and tweak it, like take the Airbnb application and be like, oh, OK, let me strip some stuff out and add some stuff in. This is more like an opportunity for you guys to learn how these apps are put together and some techniques that people in the community have used to build stuff. And there's about 15 of those. And they model native interactions that you could also see on captivate.co, C-A-P-P-T-I-V-A-T-E.co. we're hoping to have more of these interactions built because they represent what, at least in the vision of the owner of Captivate.co, the very best native kind of interactions out there. And you might ask yourself, okay, what's so special about building, a really cool slider or an expanding accordion view, or using Airbnb's really specific kind of navigation? Each of these experiences doesn't necessarily constitute a whole application. We'll be showing you how to build some of these kind of experiences today, and then we can grow you into building a whole app or incorporating it into your website. But the very best apps that you guys use aren't necessarily whiz-bang all over, right? You usually have one or maybe two of these kinds of experiences that really get you into the app, especially in the opening screen, and make you feel like wow. If you crammed 10 wow moments into one application, it would probably be like kind of overkill. Because most apps are essentially based on the table view controller paradigm, right? Like you have data, it shows up in a list, you interact with that list, that saves data somewhere else, right? That's, for all the spit and polish of a really good, well visually designed iOS application, for example, that's still the root and the core of a lot of the applications. So all you need is a little bit of this sparkle to really make your application or your website stand out. So these are examples of how to do that. So if you go to interface demos and open something like, I don't know, let's open, do we have Peak?
Oh, I forgot about it.
You didn't add Peak? Okay, let's open, well, Dots is a game. That's cool too. But let's open Airbnb. Why not? Let's open the very first one and just go to index.html. Are you guys following along? Do you guys get the framework downloaded? Awesome. So this shows you in an ersatz mobile view what this kind of interaction looks like. So click on this, and you'll see you can actually drag up and down and navigate through the different side spaces.
So use your scroll. If you guys are on Macs or PC, do your normal scroll. So that's how you, you just scroll through it. But on a mobile device, obviously, you would use your finger to drag. So instead of dragging on desktop, just use your scroll.
Additionally, do you guys know how to hook your phone up to your web browser to actually consume that content? Okay, we might be able to show, especially people who are using Macs, how to do that shortly. But if you go to app.html, you'll actually get, instead of the iframe around it, you'll get some of the goodies. Yeah, that works. You'll get the goodies actually inside of it, right? So this is going to be obviously not scale well to the desktop browser, although we can resize it. But if you go with your mobile phone and actually hit this URL on your own computer, you can actually use this the way it was intended to be used, which is as a desktop, or as the centerpiece of a mobile application. Anyway, so I think is there anything I missed in terms of the tutorials themselves? So we're going to be going through one of these tutorials today called Slideshow. It's a really unique experience which you probably wouldn't see anywhere else except by building in something like Famous. But it does demonstrate some of the core concepts that you guys have learned through the first 5 lessons in the university. So if you go to Start, this is going to give you basically, if you go to Index here, this is going to give you essentially, what are you doing?
There's a file that needs to get deleted.
Oh, okay. No big deal.
The final?
Yeah, if you go to Final, and index.html, you'll see the application that you're going to be building. So this is actually the tutorial as completed as you walk through the steps. If you go to Start, you're going to see a blank page. And that's actually intentional, because that's essentially your boilerplate from which you will build all this stuff. So we have documentation, examples, guides, interface demos from the community, the tutorials, the FAQ, the README, and the boilerplate. Everything that you guys need to get started, and it's downloaded actually quite easily. So you want to? I'll text them to remove that sync thing. Okay, so I'm going to let Shu take over from here and explain some of the core concepts that you guys, I'm sure, have questions about. And please feel free to ask questions, because this is an opportunity that almost everyone else doesn't get. You guys made a great effort to be here. You paid your hard-earned money to actually have access to us. And the people who will be here to answer your questions, in addition to the people at the front, Shu or me, are all wearing Famous t-shirts. So we have Felix, Will, Larry, Mike in the orange cap. We have Miles in the back with the even awesomer hair than me. Greg actually is in the plaid shirt. Andrew DeAndrade is in the back. Arcady, Dave. Basically, you guys have all showed up. The bus is full, so we don't have any free seats. So these guys are the ones who are sitting on the ground, outside, or on the benches on the side. Great. So any questions before we get started? I want to do some more shows of hands just quick. How many of you guys are iOS developers right now, have built one or more iOS apps? How many of you guys consider yourselves primarily iOS developers of that set? OK, so we have a lot of mostly polymaths here. How many of you guys are Android developers? One sad-looking person. OK, yeah. So you're doing both, right? You're probably do you work for a company or do you have a startup that basically builds an experience that has to mirror across both?
No, so I actually work for a company that builds tools for iOS and Android developers.
Oh, wonderful.
So, and HTML developers as well.
Great. So how many people have used such a product, something like maybe a Senchar and Accelerator, to build an HTML-based application for? OK, we got one, we got two. How many of you guys have built what you consider to be a web application, a very active front-end experience, primarily in JavaScript?
Yeah.
Wow. All right. OK, good. So we got some people who are ready to go, who won't have to relearn a lot of concepts. How about Flash? OK. All right. So a lot of these technologies sort of have that common Venn diagram intersection of essentially building something that's interactive and that's beautiful, and in many cases can scale across the devices that you care about. So this is what we purport to do, and especially if you need help using your own mobile devices to actually follow along or use basically attached to your computer to view any of this stuff in mobile. For which most of the tutorials are built, do let us know. Flag one of our guys down, and we'll show you how to do it. OK.
What about the Angular famous integration?
So the Angular famous integration is available at famo.us/Angular right now. We have to put a link in the page. We're not going to be talking about that in depth today, but if you guys are coming to the hackathon on Wednesday, we will have a session on that. So I imagine there'll be a large contingent of people who are building famous just like for the first time or straight out of the box or not using Angular. But we do have Zach Brown, the guy who created that with David Grounke, actually leading a session on that to show you guys how to combine these two technologies using this integration. So famo.us/Angular, you should be able to get it right there. All right, well, let's start with the core concepts of the render tree.
Sounds good.
Good. Thank you, Shu.
Good morning, everyone. My name's Shu. I'm extremely proud to be here in front of you guys today. This is a very exciting time for the company. Ooh, I think we just got a speaker in the back. Is that right?
Yeah.
Excellent. Great. So please speak up if you can't hear me or if you can't see anything. Sometimes, as you know, when we're presenting, the text can be really small. So if you can't see, just raise your hand, just yell out, and we will adjust accordingly. Cool. I hope you guys are well rested, have had your morning coffee, and are ready to get into some famous. Yeah? All right. Awesome. So I think Fetterman checked to see whether or not you guys have already gone into Famous University and done the Famous 101 lessons. Can I just see a show of hands real quick? Who's done the Famous 101 displaying content lesson? OK, so about half. All right, and who's done the positioning lesson? Also about half. OK, cool. All right, so a show of thumbs. Positive means I totally get it. Down means I don't get it at all. How do you guys feel about the famous render tree and modifier chaining? OK.
Sideways.
Sideways. Some people are good. OK, cool. So this concept of the famous render tree is really at the core of how famous works, how it's able to be more performant than traditional DOM and traditional HTML and CSS. So it is a core concept that you guys should really need to know pretty well as you progress through your careers in Famous. So that's what we're going to be spending some time first on this morning to really establish that solid foundation from which we will be building on for the rest of the day. Sound good? OK, so let's all go to Famous University. And let's just take a quick look at the displaying content lesson. So for you guys that have already seen this once, this will be a review. And for those of who you haven't, this will be a really quick introduction. Just a quick note on Famous University. We just refactored the website. So there's a slight bug sometimes. If you're not able to scroll on your lesson view here, just do a refresh, and that usually fixes it. We're trying to get that bug worked out, but we've been focusing on content. So thanks for your understanding there. So the first thing that you need to know when you're creating visual elements in Famous displaying content is that you need two things. You need a context, and you need a renderable. And we'll get into more details and of what that is and how you can actually map it to things you already know in HTML. But in Famous terms, or in general areas like gaming and visual graphics, a context is an isolated rendering environment. It has certain rules and constraints that define how these renderables should be rendered and positioned on the screen. And the renderable is the actual object which gets rendered by, here in our case, the web browser. And then based on the rules that we apply in the rendered tree, the browser places it accordingly. So the first example that we're going to do is it's the most basic example here. The most basic example of creating a surface. So here we see our hello world example. So line 1, we are importing the Famous engine using require. And the path that you see there refers to the module path, which you guys do. If you guys are using the Famous zip, you guys are the Famous CDN version. You guys actually won't see this, but if you've been using the generator, you have the entire Famous module structure. And if you want to go to GitHub, you're able to see all the sub-modules laid out there. But just so you know, this is where you would find the Famous engine. And this is going to be in the main.js file for every Famous project that you create. And the Famous engine is what creates our context that you see on line 4. So again, the context is the rendering environment that we need to create our Famous app. And we'll talk a little bit about how this actually maps out to HTML elements. The second thing that we import is the Famous surface. So the Famous surface, it is the core renderable of everything Famous. So it is what you actually see on the screen. It is what the DOM, or what the browser actually creates in the DOM. And then line 6 through 8, we are actually instantiating a new instance of a surface by saying first surface equal to new surface. And then in our instantiation, in our construction, we pass along an option that has the content of our surface, which is hello world. So if you want to, you can modify the content to whatever you want, and it will automatically update. So hello HTML5. Yay, super. Can you guys see this? Well, you guys should be able to play along on your own machines. So, and then the last thing is that we need to add our renderable to the context. And that is as simple as context.add surface. Here, our context is called main context. So most of your Famous apps, you're really going to just have one context for the most part. Because the more contexts you have, they're more, like I said, each context is an isolated rendering environment, right? So the more environments that you have, the more rules that the engine has to go through in order to create your app. And actually in the DOM, what happens when you create a new context, you actually create a new level of hierarchy in the DOM. Silence. Any questions so far? Yes?
Do you have to have a variable for every surface, or can you get them back out of the context by name or position or anything like that?
So the question is, can you retrieve a surface, a renderable from the context without storing a reference to it? Is that correct? I would say not easily. Yes, it's definitely recommended practice that you store a reference to your renderables if you need to reference it. Yes. Another question in the back.
Can you add text to an element?
Can you create a context inside of an existing DOM element? The answer to that is yes. You can select a DOM element already created in your HTML and then place your context inside of that DOM element. And it would replace all the previous HTML you had in there. OK.
And if you guys happen to be too shy to ask questions directly here, you can email me, Fetterman. Can you guys read that?
No.
Not at all. OK. Can we type that up?
Yeah.
It's a long room. Excuses, excuses. Or you go to an IRC channel on freenode.net. Freenode, yeah. With an R.
It's not so free. No, I'm kidding.
There's the pound famous channel, which is open always, but for you guys, if you do pound famous HTML5, just special for you, I'll make sure to be in there to answer your questions or make sure you answer them.
Yeah. Great. Yes. Questions are definitely welcome. And we, like Fetterman said at the beginning of his introduction, we're all here to learn. And we're here to learn as much from you guys as you are from us. We want to really understand where is it in our instruction, in our platform, that these concepts may be confusing so that we can improve them. Cool. So the more feedback that you guys have for us, the better our curriculum and experience will be for you guys as well as the rest of the developer community. All right. OK, great. So we just went over how to create your first surface, right? And if you want to go, if you haven't gone through the rest of the lessons on displaying content, it shows you how to style your surfaces. It shows you how to place different content types into your surfaces, how to size them appropriately. And so these are all things that you can learn pretty quickly if you have a background in HTML and CSS, because all the properties that you see here are just CSS properties written in camel case rather than with dashes as you would do in a CSS file. And then the values are in a string format. But what I want to focus on is more on the, I guess, the concept of the rendered tree. So we can work right here with our basic surface example. So the difference between the rendered tree, the famous rendered tree, and the DOM tree is that the famous rendered tree is really an abstract concept. It's really an abstract concept based on JavaScript objects. Whereas the DOM tree, it actually produces a nested structure. So if we right-click and then we inspect element on our app here, this is the entire Famous University app is written using Famous. And if you scroll up, I know this is really hard to see probably, so I'm going to pop this out. There we go. Okay. You guys see this? Okay. So what you guys see here is that there is a div element on our page here, and it has a class famous container, and it actually has a WebKit perspective of 1000. So this is actually what gets created when you create a new context on using your famous app. It creates a famous container, but it's actually a div element. So the famous container serves to be the isolated rendering environment. And then down through here, you'll see a long, long list of divs with the class famous surface. And what you'll notice is that unlike most, if you guys ever go to a Google website and then you do an inspect all or inspect elements, they nest the heck out of their DOM elements. They go like dozens of levels deep using their DOM. And the difference, what we're doing, if you look, you can see there's this WebKit transform matrix 3D, and then you'll see a long string of numbers there. There are actually 16 numbers there, which represent a 4x4 matrix. And this 4x4 matrix is what's telling the browser how to position, rotate, and scale and skew these div elements so that you're able to see these surfaces in 3 dimensions. And then you're able to animate them extremely quickly. So we are bypassing the default CSS positioning that you guys are probably familiar with using position relative or even position absolute with top left, bottom right, et cetera, et cetera. So all of the famous surfaces are positioned with absolute positioning. And it is, as you can see here, position absolute. And it is the transforms that dictate how they should be positioned. So the famous engine goes through your render tree and then constructs all of these properties onto your DOM elements, and then that's what gets actually rendered onto your web screen, onto your monitor. Does this make sense so far? So what I wanted to show you here is that although we may have nested hierarchy in our DOM, although we may have a nested structure in our famous render tree, where we have node after node after node, and then the surfaces are levels deep, in the actual DOM tree, it's actually a flat structure. And by having this flat structure, we're able to have better performance. OK, so let's actually get into some examples of what this would look like. I'm going to go to Illustrator here. And open up my last file. So what we're going to do, we're actually going to draw out what the render tree looks like as we build some of these scenes in Famous. OK? So can you guys see this OK in the back? Yes? Great. OK, cool. So I'm using these shapes to represent the different node types that we're going to be exploring in the famous render tree. So here we have the context that I just talked about. We have surfaces, which I also mentioned. So the context is the rendering environment. The surface is the renderable. We have modifiers that instruct the render engine, or sorry, the famous engine, how to modify different branches in the rendered tree. And one way of doing so is applying those transforms that I just talked about. And then nodes are these are just abstract objects that we can store in reference that point to certain nodes in the rendered tree. And you'll see why those are useful in a second. OK, so the example that we just looked at, where we have engine create context, and then context.add surface. So what we have now is we have a new context, and then we have a new surface. And there is a line connecting them. All right, let's see here if I can get this to zoom. Very simple, right? So this is what the famous render tree would look like. And let me just write out what this will look like in the DOM. So let me move this. We'll have a div element. So this is class container, like you guys just saw. And then underneath that, it would have a div with class equal to surface. And I'm leaving out the prefix of famous, but you guys should know that these are the famous container and the famous surface. Okay? So let me exaggerate this a little bit. Let's see the tabs. There you go. So you can see that the yeah, there we go. The surface is nested underneath the context in the DOM, right? So this makes sense. We have a hierarchical relationship here. We have a hierarchical relationship here, all right? So what we can do, we can actually now create more surfaces or more modifiers to add to this. All right, so now let's say we have, if we go back to Famous University, and then we go to the positioning elements lesson, we're going to take a look at step 5. So you can go to positioning/5 and branching modifiers. So what we're doing here is we're actually creating two surfaces, and they're positioned next to each other. But we're doing so by creating a branch in our render tree. So we have two state modifiers that we have created, okay? And one of them is controlling the position in the y direction of how far down these surfaces are translated. And another modifier, the right modifier, is translating this black surface to the right. So on line 9, if you change that value, 125 or whatever you want to change it to, you can see these surfaces move down together. So by changing one modifier, you're able to change both surfaces. So this is one misconception a lot of people have about Famous, is that they think because a common coding pattern is what you'll see is note or context.add a modifier.add surface. So in order to position a surface, you add a state modifier. But they get this incorrect notion in their mind that modifiers and surfaces have a one-to-one relationship, where actually modifiers are just changing portions of the rendered tree, and anything can be under that rendered tree, that branch of the rendered tree. Okay, so let's draw this out again. So here, we have one surface. So so what we wanted to do is to move, we're going to create two surfaces, and we're going to move them down together. Okay? So I'm going to move this over. I'm going to take a modifier. I'm going to copy this. Copy. So if we take a look at the code, what's going on line 34 there, we're storing a node to main context .add down modifier. All right. So here in our diagram, we've added this modifier to our context. So this would represent the down modifier that you see in the code. And what we're doing now is we're going to create a render node that stores that reference in the render tree. Okay? That's fine. And then we're going to add. So now that on line 35, we're adding the left surface to that node. Okay? And then on 36, what you see is that we're ready. OK, let's do that first. So what I'm going to do is I'm going to branch out from this node. Whoops. And I'm adding this surface here. So this is what the diagram of our render tree looks like up until line 35 of that code. Are you guys all following along in the lesson? Can I get a thumbs? Yes? Great. Thank you. OK, cool. So now on line 36, what we're going to do is we're going to add another modifier. And then adding a surface below that modifier. OK. You guys see that? OK, so now we have this tree structure created. And as you can see, there are multiple levels of render nodes and modifiers. But what you'll actually see in the DOM is not very different than what's already there from the previous example. You'll actually just see another surface created as a sibling of the previous surface, even though that these guys may be on a different level in the render tree. So I could add more nodes, more modifiers, and as long as I'm adding to the same context, in the DOM, what you'll see is that those surfaces are siblings of each other. And they actually don't follow the same hierarchical relationship that you actually created them using the render tree. All right, does that make sense? Can I get a thumbs on whether or not this clears things up a little bit? Super.
Can you touch a little bit as to why that's so much more optimal for the DOM? Like, why isn't it here?
Where's Felix?
Hey, Felix? Mike?
So can you repeat the question?
Well, I was just curious. I mean, if it's something we can touch on later, it's fine too. But I was just curious why it is that multiple levels of nesting tend to be so tough for the browser to handle.
So the idea is that by having them all in the same layer and not nesting them, we can essentially pull out pieces that you don't reuse. So when you end up having multiple contexts inside of the context, that's what ends up happening is you get that nested effect. So what ends up happening is you run multiple interludes to recalculate everything. So by keeping everything in one layer, you're getting the map performed on the same perspective, and it allows us to easily pull in and out surfaces that aren't being used. Scoping will call out surfaces that are too far away out of the tree. So it gives us better control over it's all simplified.
Great. Awesome. Great question. Great clarification by Mike there. So this is actually a pretty cool thing to understand. So the question was, why is it more performant to have a flatter hierarchy in the DOM? And Mike's answer was, it's easier to retrieve these items and swap them out and then apply changes to them if they're a shallower hierarchy. Yes?
So after the first modifier, you get an instance of the node.
Right.
After the second modifier, do you get another instance of the node, or is it the same node?
Correct. Well, no, you can save. So what is not shown here is that there is a node that gets created, but by just chaining our add methods here, by just calling add again, we are just adding to the node that's returned to us here. So you are correct that there is a node after this modifier, but I just didn't show it here.
Yeah, so that means if somebody accesses the original node that has been stored,
yes,
it will not have the second modifier, it will only have the first modifier.
That is correct. Exactly. Exactly. So that is how you're able to move these two surfaces together in the y direction and then move this black one separately in the x direction. Because only this top modifier gets applied to both of these surfaces, and this bottom modifier gets applied to only this one surface.
So every modifier returns a new reference.
Sorry?
Every modifier returns
Every modifier is a new instance.
Every application of a modifier to a node creates a new node.
That's correct. Yes. Good question. Very good question. Yes.
The modifier before it's added to the context or to a node or whatever, can you reuse the modifier object?
The question is, can you reuse a modifier in the render tree? And Mike is firmly shaking his head, no. So that is something that, so the answer is no. Right, so you have to create a new modifier. So you can't create, so say you're using a modifier to center something. So you're using origin 0.5, and now the new align 0.5. You can't reuse that modifier as if it was, say, like a class. So each modifier is unique to its position in the rendered tree.
So as soon as you add it to something, that object is being used in something.
That's right. Great question. Awesome. Yes?
One thing which is not mentioned very often in the existing stuff is the order in which you create the surfaces is not necessarily going to be the order of the DOM elements which are created.
Right. The question.
You expect one thing to be overlapping another, but it's not necessarily going to be true when it gets rendered. They might be in a different order unless you explicitly override the z index.
So you're asking about how you would layer things?
All the expectation people have when they create the surface, a certain order is how they expect it to show up in the DOM, which is not necessarily true.
Yeah. Yes, that is correct. The order that you create your surfaces, your renderables in your JavaScript may not necessarily correlate to the order that they appear in your DOM.
But you shouldn't be relying on the order for layout, right? Like we basically take away, between surfaces, we're basically removing the DOM, like the block and inline layout, right? So you're using absolute positioning, using our transforms and so forth to do the layout. If you're worried about z indexing, I would set the index or actually use transforms in 3 dimensions depending upon the application.
Yeah.
I'm actually going to be talking about this afternoon.
Right. So we're going to be touching on that. But the short answer is you are correct. And if you want to control the order, the way that your renderables are displayed when they are on top of each other, you would translate them in the z direction. Because again, remember, your famous surfaces are laid out in 3-dimensional space. So the things that are positioned closer to you, higher in a z value, the z translation will appear on top. I mean, there's some special rules that you need to be aware of, but that is how you would position things so that you see one on top of the other one. And also applying z index at the CSS property in special circumstances.
I mean, this might be a small thing, but it's just how you're showing it visually here. You're showing the context and you're applying a modifier to the context, but kind of show the surface and so the modifier and the surface is reversed. I don't know, is it visually, should you show the surface and then the modifier?
I'm sorry.
So you show context and modifier, right? And then down at the bottom here, there's a surface with a modifier.
Right. So the context is the root of our tree.
Yeah.
So we're adding the modifier to the context, and then everything below.
So you're not adding the modifier to the surface.
We are adding the surface underneath the modifier.
Okay, so it's different.
Correct. Yes. So it goes upwards. So you can think of, so first what will happen is that this modifier gets applied to this surface to create this branch of the tree. And then this modifier gets applied to everything below its branch of the tree. Does that make sense?
Hi. So you explained context, you explained surface, you explained modifier really well. Node, you didn't really explain what it is and what the equivalent is in HTML.
Correct. Yes. Like I said, a render node is a JavaScript object. It's an abstract object that doesn't actually have a mapping to anything in the DOM. So you'll never see a node element in the DOM. That's a very, very good question, and it is a very good point that you guys should try to really integrate into your understanding of Famous is that render nodes do not have a mapping to an actual DOM object. As we continue today in talking about views, and as we continue to talk about views and other widgets and renderables, they're going to be creating multiple render nodes in our render tree, and you'll never see those render nodes displayed in the DOM. So you can create a new view, and you'll never see a DOM element with a view class. You'll only see the surfaces that you've added to those views. Okay. I actually don't know this one.
What?
Do you want to talk about this? No. Okay. Yes? Can you dynamically add and remove modifiers?
Add a modifier that does some animation when you're done with it, remove it again from the tree.
So Valdi or Mike, do you want to explain why you actually cannot remove something from the tree?
Yeah, so the idea is that when you create your scene graph, you create it once, and anything that modifies the scene graph will be left up to different components. So this kind of gets to the idea of what a render controller does. So what a render controller does is essentially like swapping out different branches of your tree for you, whereas you don't actually want to modify the scene graph yourself.
Right.
It leads to some like really wonky things. You technically can, but it's not ideal. I mean, you can essentially call out like exactly, not call out, but like remove what a modifier does by resetting all of its properties. But for any post scene graph construction, it should pretty much be done via render controller or lightbox or any of like the pre-composed componentry for that.
Yeah, we have basically widgets that do that for you, and like that sort of show high case is actually what Mike just said about render controller. So we'll go over some of that stuff this afternoon if that works.
Yes, you'll see some of that in the slideshow tutorial. So what that means for you as you're building your Famous app is that you need to think ahead about what animations need to be done in order to make you need to think about the architecture in terms of, okay, these are the things that need to move, so I need to store a reference to this modifier. Or I need to create a new modifier because I'm going to use it later to carry out a certain animation. So that structure needs to be created when you build your app. But great question. All right. I think we're going to move on, and if you have any more questions about the render tree, please address them to Fetterman or the IRC channel.
Yeah, we got a lot going on in there.
Yeah,
so that's good.
Great. So I think right now we're at a place that we can go into the slideshow tutorial. So let's do that. Let's go to Famous University, and hopefully you guys will have gone through most of these lessons. And if you haven't, you can either run through them really quickly, or if you feel like you're experienced in web development, you can probably jump into slideshow and figure it out as you go along. So go ahead and open up the slideshow tutorial. And what you'll see is that you'll get a preview of the final app that we were going to be building. And as you step through the different lesson steps, you'll see the different animations, the different stages of the app that are being built. And there'll be diagrams as well as code blocks to help you along. So myself and the rest of the TAs are going to be walking around and helping you guys along as you go through this tutorial. And we may actually...
Start a little bit.
What's that?
Let's start it together.
OK. So let's all go into our start folder in your Famous zip, and then open up the project in your code editor.
So, the reference tutorials, slideshow start.
That's right.
Yep.
Okay. Great. So if we go into, in the start folder, there is the source src folder. And then you'll see there's the main.js file in there. So that is going to be the entry point, the JavaScript entry point into our app. This is what if you guys look, you'll see the familiar line of var engine equal to require famous core engine, and then creating our new context, as you just saw in Famous University. The new lines of code on lines 1 and 5 are defining our module, and we are using require.js to keep our code modularized so that you can import different classes and maintain namespacing. So the lines 1 and 5 will be at the beginning and end of every single new JavaScript file that you create in Famous. Also in our folder structure, you'll see there's the CSS folder with the CSS file. That is just some basic CSS styles that we'll be using in this project. You won't have to modify that. And then in the image folder, we have a camera image that you'll be using to build our app with. And then lastly, in the data folder in source, there is a slide data.js that we have created for you. So you guys don't need to worry about this. We'll just simply be using it. Essentially what it's doing is going to a Google Plus album, grabbing the images from a public Google Plus album, and then populating your app with those images. So if you have a Google Plus album, if you want to create a Google Plus album, just make it public, and then you can enter in the album ID and the user ID, and then it'll show you your own photos, which is pretty cool. Then also lastly, the index.html is the web entry point for your app. So this is what you would open in your web browser, and it would show you your app. And required in are all the famous .min, as well as the style sheets and other JavaScript code that you will need to make your Famous app run. And also, most of the time, you will not need to modify your index.html. You'll simply just view it or serve it, and it'll show you display your Famous app. OK, very cool. So yes, let's walk through a couple of the steps in our app. So this is the finished version of our app that we should see. So let me pull it up in. So this is essentially what you'll be building. It is a slideshow app that as you click through, it shows you the next image. And like a Polaroid camera, it shakes it until the image comes into full opacity. And what's really cool about this process is that this is, although we're making a specific slideshow app with the Polaroid feature, what we're going to be building are you can change any of the transitions from slide to slide. And it's extremely easy to just configure this with a few minor lines of code, and you'll see how to do this so that you can make it come in from the right or bounce up from the bottom, fade in, or in this case, it's going to be rotating. And so the way that we're going to be building this app is it's diagrammed here in this wireframe. So we're going to be constructing our app using multiple views. So some of you guys may be familiar with the concept of views through MVC frameworks, Backbone, et cetera. But as I mentioned to you earlier, is that views are just fancy render nodes. They're abstract objects in JavaScript that help us organize and encapsulate our surfaces. And we can actually create modules out of them. So essentially classes, and we can create multiple instances of our views. So for example, our slide view here is the first view that we'll end up putting surfaces into. And the slide view is actually, is the actual Polaroid slide. So as we flip through our album here, we're going to be creating multiple instances of the slide view, which is why creating these views is really helpful. And then we have the slideshow view, which contains a lightbox, which what Mike mentioned earlier is our component, our famous component that is swapping in and out these renerables. And then at the highest level is our app view, which contains our camera surface and then also our slideshow view. So this will be where we source a lot of the data in. This is your top level app view that you're going to be, that's going to contain your entire app. Okay, so let's jump into what a boiler code view looks like. Okay, so I've just copied and pasted the code from Famous University into a local file here. And this is called empty view. This is our boilerplate template for a new view class. So the view classes that we're going to be creating in our app are the app view, the slideshow view, the slideshow, yes, view, and then the slide view. So right now it's called empty view. So let's save this file locally inside of a views folder. So we're going to create a new folder inside source called views. And then inside the views folder, we're going to call this emptyview.js. Okay, so there's some inline comments that tell you what's going on in the code. The first define statement we already talked about. You guys are familiar with the dependencies. We mentioned that earlier, but let's review them again. So the first one is the view class that's in Famous Core. So that is the superclass we're going to be extending from to make our class. So the view class contains different methods and that are going to be very helpful that we're going to be inheriting from in its prototype. And in the constructor, what you'll see is that we're calling view.apply this comma arguments. So essentially, we're going to be taking all of the constructor code in the view class, and we're going to be applying it to our custom view class. Okay? And then line, I lost the line numbers. This line that says empty view.prototype equal to object.createPrototype, and the one following that, essentially setting up the prototype chain so that our custom view inherits from the view class. We are creating an empty view.default options property on our view class. As you go along, this will be used to take in the arguments passed into the constructor and then create a this.options object in your view class that can be accessed. And then lastly, we have a module.exports empty view so that when we require in this view in another module, it will refer to the class that we just created. OK, I know that might have been a little fast, and I saw a couple hands up. You had a question?
Yeah, dealing with work emergencies, so I missed where you got this code from.
Oh, gotcha. So if you go to the slideshow tutorial, and then slide 5. OK. Are we all good on this? Yes, thumbs? Up, down, middle, not sure. Please have your thumbs up. OK, great. So I think you have a question. Well, so I think the lady in the third row had a question. Do you mind just like helping her out? Thanks. OK. And then in the section below the default options is where we would typically define our helper functions, any private functions in this class, and then also add on prototype methods for this class. All right, so the first thing we're going to do, now that we have our boilerplate code, I'm just going to delete, oh yeah, I'll keep the comments in. We're going to create a new app view. So app view is the top level view in our app. and we're going to create a new app view. So let's save this as appview.js inside of our views folder. And then we're going to rename all the references to empty view to app view. Okay. Delete this. Okay. And now we're going to go into our main.js. We're going to import our app view. So var app view, the class, and then require in views/app view. And then after we create our context, we're going to create an instance of app view. Notice that this is lowercase a, and using the the word new, specify call our constructor here of app view. So now we have a new instance of our app view, and now we're going to do main context.add app view. So for those of you guys that are following along to me, if I'm going too fast or too slow, all of the instructions are in Famous University, so feel free to go at your own pace. Otherwise, you can follow along, and we'll get you started here. I don't think we want to do the entire thing here, do we? We'll just go for a while. Okay. All right, cool. All right, great. So now that we've added our app view, we can go to our local app. So this is start index.html. And if we refresh, we see that it's still blank. And if we open our inspector, inspect element, okay. And open up body, you see the famous container. So we've created a context, but notice that it has no children. And again, while we've added a view, there's nothing in the context because we haven't added any surfaces. We haven't added any renderables. And this is actually going to continue until we add our first surface. Unfortunately, our first surface is going to be in the slide view class, which is nested inside of the slide show view class. So we're going to have to create a new class called the slide show view. So go ahead and save your boilerplate code as slideshow view.js, and then save another copy as slideview.js. And then in each of these files, rename all these references appropriately like we did for app view. So again, the process is you save a new copy of the boilerplate code as the slideshow view or slide view, and then you go in and then rename the classes and change all the references to the one that you want. Yes, question?
What is exactly in the university? Is it the same thing, or are you doing?
Yes, this is the same thing that's in the university.
Right. So we can let you guys run for a little bit and then branch off and then modify some stuff too if you like. So if you want to say, hey, look, why don't we make it spin the other way? Like, I'm sure we could totally do that if you guys want.
Okay. Great. So now what we're going to do is we're going to go into our app view. We're going to import our slideshow view. And then we're going to create a new instance inside of our constructor. View. And then, so this is where it differs from previous. So previously, we created an instance of app view, and then we add it to the context, right? Now what we're going to do is we've created the instance of our slideshow view, and now we're going to be adding it to the app view. So inside app view, when this gets called, the reference to this instance, particular instance of app view, is going to be through the keyword this. So we'll write this.add slideshow view. So now in our render tree, we're going to have our root context. Below that, we'll have a render node that is the app view. And then below that, we'll have another render node that is for the the slideshow view that we just created. Okay. And if you go back to your app, your local app, and you refresh, again, you still don't see anything underneath. You don't see any other elements underneath your famous container because we haven't added any renderables. So again, this is to reinforce the idea that while you're adding objects to your render tree, until you've added a renderable, you don't see anything in the DOM. OK, great. So we've added slideshow view. And we're going to repeat the same pattern in slideshow view to add the slide view. So again, we are in slideshow view.js. So we import slide view. It's equal to require. Path is view/slide view. And then in our constructor, actually, what we're going to do this time, we're going to create a helper function to do so. So we can declare a function called create slide view. I forget exactly what the name that I used in the tutorial was. Oh, no, I just added it. OK. But we can do this too. All right, anyways. So we can call this create slide view, define our function. And then inside var slide view is equal to new slide view. And then this.add slide view. And then, of course, call your constructor, or call your helper function in your constructor using this pattern of .call this. And then the context is this. Calling the function in the context of this, of the instance of the slideshow view. OK. So this work, all of this work has led us to the code inside of slide view. OK, so now we're actually ready to start adding surfaces to our render tree. Almost. So yeah, actually, let's do that. Let's do something very basic. Let's create a new surface. So var surface is equal to new surface. And then we're going to pass in content hello world. And then we're going to add the surface to our slide view. OK. So now if we refresh, you may not be able to see it very well. But there it is, hello world, finally displayed in our DOM as a child of our container. So again, conceptually, we have what we've created so far is an app view, a slideshow view, and a slide view, all nested within each other, and the app view is added to the main context. But what you actually see in the DOM is you see one div with another div below it. So the DOM hierarchy, again, does not correlate to the hierarchy created in JavaScript in Famous. All right, so the next steps in the tutorial will be to add these different surfaces to our slide view so that we ultimately, oops, this should have been, I feel like I'm missing a step. Oh, there we go. So that we ultimately build this slide here, okay? So this slide, the slide view is actually going to contain 3 separate surfaces. There's one for the background, the beige card here. There's another surface, which is the black border. This black border could be done with CSS, but if you remember the final app, this image actually fades in from black, so we need to create a separate surface for it. And then we create another surface for the actual photo image. And so these 3 images, these 3 surfaces are actually stacked on top of each other, and they're all contained within the slide view. Does that make sense? And then this slide view serves as a class that essentially is the constructor for multiple instances of these slides. And all we have to do is pass in the data option to say, this is the photo URL to use for this particular instance. So that is the general roadmap for how we're going to create multiple slide views. OK, any questions here? How does the code, how do you guys feel about creating the boilerplate code? Can I get thumbs of your understanding of the view code? I only saw like 5 thumbs. Come on, guys.
They can be down.
They can be down. Seriously, like if you don't raise your hand, I'm going to assume that we lost you somewhere. So please, once again.
I would say just a comment like creating all the view boilerplate. I think could already just be in there.
Right.
It's kind of redundant to just change the class name for each one. So.
Right. So the generator, if you guys were using the generator, you just type the yo command, yo famous view colon, or yo famous colon view something, right? But this, so in the next tutorial, the empty view is there for you. So you're saying for the tutorial in general, like pre-create these?
Like with the starter kit, maybe the folder should already have like the boilerplate.
Gotcha. Yes, we thought about that. I think it's actually worthwhile to go through the process of creating this, especially in your first time, because you get more familiar with, OK, so this is my boilerplate code, and these are the places I need to change it, and this is where I specify all of my different private functions and methods and things like that. Yeah. But yes, thanks for the suggestion. Yeah.